Today's lecture is Introduction to Geotechnical Engineering. If you remember, in the previous lecture, we took Introduction to Geotechnical Engineering. But this time we are going to take Introduction to Engineering Geology. What is the difference between geotechnical engineering and engineering geology? We discussed this in the previous lecture, but let's just remember it with this slide from the previous lecture. We said that geotechnical engineering emerges from two main sciences, geology and hydrology, because geotechnical engineering deals with soil and deals with water. So we need to study the science of soil, which is geology, and the science of water, which is hydrology. We said that the science of water, we can study it during our study in geotechnical engineering. But geology, we need to take introduction for it. We are not going to take introduction that is given to geologists, but we are going to take an introduction that is given to geotechnical engineers or to engineers in general. So we are going in this lecture to study basis of geology that we are going to discuss during this course. What is the difference between engineering and science? Because geology is a science, hydrology is science, but geotechnical, it is engineering. So what is the difference between science and engineering? We said that science describes the problems, studies the problems all around us, describes everything around us, puts equations for this study, everything, but they do not propose solutions. They just tell you that you will have an earthquake. It will be with the specific intensity and at a specific location and so on. They will give you all the data. But how to deal with this earthquake? Can they tell us how to build a building that would not be affected by this earthquake? No, they will stop. The engineers propose. They take what scientists propose and give it to engineers so that they design. What they are going to do, they are going to analyze, design, and construct these structures or buildings that can solve the problem. What is geology? Geology is the science of Earth. It deals with Earth, dealing with its composition, structure, and geological history, as well as studying the origins, properties, and compositions of both rocks and minerals. So geology is the study of everything related to the Earth. Geology also studies the Earth's history 4.5 billion years ago. So that's why this is the main difference between engineers and geologists. When you discuss anything with a geologist, he is going to tell you that this site was created maybe 1 million years ago, and during this million years, this happens and this happened and so on. But for a geotechnical engineer, he does not care the history. He need to study what is the properties of soil now. Can it carry loads or not? What will happen in the future? What is expected to happen in the future? So geologists study the history. Geotechnical engineers just need what is the situation now and what is expected to happen in the future, so that they can build their buildings that can carry these conditions. So we study the Earth. The Earth's surface, oceans, ocean floor, and the interior of the Earth, because the interior of the Earth affects the crust of the Earth. What is the cause of earthquakes? Earthquakes is something happening below and it emerges to the top, affecting the surface. So if I know what is happening below, then I can a little bit expect. So far, nobody can expect earthquakes. We will discuss this in a special lecture. But the expectations are still minor and not very accurate. But it's science, and it is improving with time. Maybe in the future they can have a very good expectation for earthquake. Just also a reminder from our previous lecture, why do we study? We saw this picture in why do we study geotechnical engineering, but it's also why do we study geology, because the main problem is a problem in the geology of the earth. If I know the geology of the earth, I can prevent a problem like this. Here also, this is why we study geotechnical engineering. So this is the difference. Geology, we study the problem that is below the earth. But if I know geotechnical engineering, I can design buildings that would not affected by the current conditions. If you remember, we said that the problem of this building was due to construction. During construction, they excavated in front of the building, piled the excavation below the building, at the back of the building, and it started to rain heavily. So this was the result of the collapse of the building. So what is geology? Let's start counting. You see how many terminologies here? Of course, for this slide only, you don't have to memorize all of this. Just you will know what is important later and what is not important. But when I tell you what are the branches of geology, you have two main branches. It is basic branches and applied branches. Basic branches: physical geology, geomorphology, structural geology, stratigraphy, lots of fields of geology. Applied branches, we have many: mining geology, engineering geology. This is the term that we are studying now. So this is exactly what we are studying this term. All of these are other supporting branches that we may need in our study, but we are now studying engineering geology. What do I mean by applied branches? It means that it is an application in the field, application in the site. But the basic branches are more or less science. We are just studying the science of all of these. But these are applications in the field, like say here mining, drilling mines, well logging, drilling wells. So these are all applied fields. What are the important? You may start counting the number of terminologies from here. What are the important branches of geology? There is something called physical geology, and this is the definition of it. It deals with the origin, development, and the ultimate fate of various superficial features of Earth. It has an important role in earthquakes and volcanoes and something like this. So physical geology, it deals with the origin, development, and the structure of the Earth. Geomorphology, it's the branch that deals with the features on top of the Earth. What is the surface features? What do we see on top of the Earth? Mountains, valleys, plateaus, reservoirs, and so on. So geomorphology deals with the shape of the Earth. So these both you have to know it, because you may be asked in one of the multi-MCQ questions the difference between geomorphology and physical geology. So you need to know these two terms. Other branches of geology: structural geology. Structural geology, this is very important. We will have a lecture dedicated for something like this. It deals with many things that are very important. I don't know if you have heard about it or not before. There's something called folds and faults, joints. I think in Arabic you may have heard the word fawaliq. Did you hear before something? We said that we have faliq, fault at a special place, and they tell you that don't build in this area because it includes something like a big crack, fault. So this big crack, if I put my building on top of it, it means that the earth below the building may move relative to each other. The earth below the building may be divided into two parts. One part would move in a direction and the other would move in another direction. Imagine a building on top of an earth, and below it the earth is divided into two parts, each part moving in a different direction. It's a big problem. Any building on top of it will fall. So this is very important. Historical geology, of course, it deals with the history of the earth. Mineralogy, we will have a chapter for this item. It deals with the minerals inside the soil. If I have a material, this material, it consists of smaller minerals inside. So I need to study the basic minerals, so that when I know the properties of these basic minerals, the combination of these minerals together would give me other components that I need to study. Petrology, minerals occurring in natural aggregated from form are called rocks. Here it deals with the rocks and the texture of the rocks and how they are formed. Other thing is the branches of applied geology. We said that we have basic branches and we have applied branches. So if we go to the applied branches, these are the important, of course, engineering geology. This is what we are going to study in this term. Economic geology. If you remember a long time ago, of course you were not there, but what were the sources of energy? Fahm, coal. This was very important. It's now like oil and petrol, and so coal was once a very important source of energy, and maybe countries would fight for coal. So coal as a material is very important from the economical point of view. It means money. Something now like oil. When we say that oil countries are very important because they have this material, it is also the same. So some material have very high price. So these are economical geology. So we study this, and of course we said engineering geology. Why do engineers study geology? Now, as an engineer, why are you going to? Now you knew what is the different parts of geology. Why are we going to study geology? Because if we know why are we going to study geology, then we do not have to study all of these, because all of these are things related to geologists. We are not geologists. We only need few branches that will help us in our study. So what are the target of our study? The target of our study as engineers, not civil, any engineers, to study valuable resources such as soil, rock, water, metals, industrial materials, and energy. So there is an economical point of view that engineers would study. I may study in civil engineering. We build using sand. We build using gravel. We build using many materials that are coming from soil. So if I study it, then I am saving money to get the most benefit out of it and know where to find it. So the first thing for engineers to study geology is to know the impact of this material on the economical part. To study rocks and fossils they contain, to understand the evolution of our environment and life within it. Some branches of engineers are dedicated and study the evolution of the earth and the environment, especially environmental engineers. They deal with the origin of the material, how it was formed and what will happen to this material in the future. Would it disintegrate? Would it change from one type to the other? So it is another reason for studying geology. To learn to minimize our risk. This is what is very important for us as civil engineers. To minimize the risk of earthquakes, volcanoes, slope failures, and damages due to storms. This is really what is very important to us as civil engineers. To learn how and why Earth's climate has changed in the past and use that knowledge to understand both natural and human-caused climate changes. If you remember some cases, they were studying the effect of the ozone on the environment and how the energy along the earth is going to increase because of this hole in the ozone. And so the effect of the geology and because geology also includes the atmosphere around us. So the atmosphere around us affects our earth. Let's first look at the earth to know what because now we said something related to the bottom of the earth and we said something related to the atmosphere around us. So these are what we deal with in geology? Yes. The earth, this is the earth. What is the earth composed of? The inner of the earth is composed of three main layers. An inner core, an outer core, mantle. So the core is divided into two layers, inner core and outer core. Then we have an intermediate layer, which is the mantle. Then we have a very thin crust on top of them. These are the three layers inside the earth. But what about outside the earth? We have the atmosphere. It is part of the earth. Any planet has an atmosphere around it. Some planets may not have an atmosphere. What is atmosphere? Atmosphere is the trapped gases around the planet. These gases may change the planet to be inhabited by people or not, because if you don't have atmosphere, then you cannot live on this planet. Let's look at the atmosphere. This is the earth. Imagine that if this is the diameter of the earth, this is the thickness of the atmosphere. It's about 350 kilometers. By the way, in geology, you will find many reference books. And if you open any reference book, you will find that you may have different values. You may find here in this lecture that we are saying that the thickness of the atmosphere is 350 kilometers. But you may open another reference and you find that it is only 300. It's the same. But you will not find it in one reference that it is 600. It will not be the double. But we don't have accurate values in geology. always values are approximate. So if I say 350, it means that it may be 250, it may be 400, it's all within range. These are the layers of the atmosphere. So now let's discuss how many other items that you need to study. Ionosphere, this is the outer. Mesosphere, this is the inner. Stratosphere, this is the innermost. Tropopause, this is a layer, just a small layer. Ozone layer, this is another small layer, and this is the Earth. See? No, the distances are also, here they say that it is 90 kilometers, maybe in another it would they say 100 kilometers, and 80 kilometers, but it is relative. If I say this would be just the shape, if I say that this is not 350, it is 400, maybe I would find this instead of 90, I find it 100, and so on. But it is all in range. But you will not find the opposite. You will not find that this instead of 90, it is 300, and this instead of 350, it is 100. No, the outer is the outer, the inner is the inner, the in-between is the in-between. Distances are always not the same, but it is within the same range. But I want you to guess how many. Imagine that you have a question, an MCQ question saying that the stratosphere is so and so. And you don't know what is the stratosphere and what is the troposphere and what is the ionosphere, then you will not answer. It is very, if I have this lecture in front of me and I have the question, I will answer all questions correct. It's very easy because I will just look and answer. But unfortunately, you have to memorize these terms. So you have to start from now. I propose for you something. Start putting your terminology lists. Open a file, start with the headings. Say development or the earth, what is below the earth, crust, mantle, core. Okay, these are you are going to write this. Then the atmosphere. I will take the important layers and put the names of it and put a small description. Ionosphere, this is the outermost layer. Then this is the inner layer, and so on. This is, by the way, another, if you look here, you will find that this is another reference giving the same layers. This is the earth and this is the layers. More or less they are the same. Troposphere, ozone layer, stratosphere, they are the same layer. But if you look at these distances, you will find that it is different. That's why I intended to put from two references so that you know that it is not a fixed number. Nobody has gone to the outside and said that this is the boundary between the mesosphere and the thermosphere. By the way, the name here is different from the other name. But for the atmosphere, just know the differences, because we are not going to concentrate a lot on the atmosphere, because we are mainly studying the Earth, not the atmosphere of the Earth. But the atmosphere of the Earth we studied for additional knowledge, just additional knowledge. When we go to other terminologies, I will tell you that this is very, very important. Let's go to the Earth. We said that the Earth consists of three main layers. The three main layers are the core, which is divided into inner core and outer core, the mantle, and a very thin crust. These are the main three layers. The the core is divided into two parts, we said, inner core and outer core. The inner core is a solid part. The outer core, this is a very, very important information, because it helps us as engineers to study something that we are going to discuss later. But you have to know that the core of the earth from inside is not all. Imagine that we are now standing kilometers away, there is liquid. We are standing on top of liquid that is very, very hot. So the inner is a solid ball, followed by liquid, but it's not a very, very hot liquid. Both together are called the core, inner and outer core. Then we have the mantle. Also the mantle is divided, but let us discuss it later. And then we have the thin crust. This thin crust, it may reach 100 kilometers. It is thin, but it means that it may reach 100 kilometers. In some literature, you will find that they are telling you that the crust is between 5 and 70 kilometers. We will come to this in a special figure here. Let's discuss this. This is the core. This is the inner, the core, the inner core, and this is the mantle, and this is the thin crust. Of course, it is not drawn to scale. This thin crust, it is very thin here below the oceans. Below the oceans, the crust is very shallow, very small. But if you go to the land, you will find that the crust is bigger than below the oceans. Here we have, we studied the crust. We should go below the crust and study the mantle and the inner core. But before we go to the mantle and the inner and the core, we have few terminologies that we have to understand, because they are used a lot in many cases. There is something called biosphere. You can compare this to the layers of the atmosphere. You will find that sometimes the name biosphere may be something like the ionosphere that we have studied in the atmosphere. It's a little bit confusing, so you have to be to understand what each terms mean. So there is something called biosphere, and there's something called hydrosphere. Let's try to understand. Bio comes from biology. Hydro comes from water. Hydro is, when we say hydropower, it's the power of water. So hydrosphere deals with water, biosphere deals with biology. So the region of the crusts, not only the crust of the Earth's surface and the atmosphere of the Earth or another planet occupied by living organisms. So scientists said that the biosphere is everything that includes living organisms. Of course, if I tell you the core of the Earth, there is no living organism can live at the bottom of the Earth, because, by the way, the temperature of the core of the Earth is more or less equal to the temperature of the sun. So it is very, very cold, very, very hot at the bottom. And if you look here on the surface of the Earth, you will find that there are areas with snow. So it means that the temperature is below zero. So it means that the Earth has something very peculiar that can change the temperature from the temperature of the sun at the core and decrease it when we reach the surface. It's have a cooling system. There is a cooling system inside the Earth that helps the temperature of the Earth to be reduced from nearly the temperature of the sun to snow and ice. So this is a very thing that we have to consider, that there is something here in between that works as the radiator of the car. If you know, the radiator of the car cools the car. So there is a cooling system here. This cooling system helps to cool the Earth. How this happens? There is something called convection current. What are convection currents? Here the temperature is very high. So, and we said that there is something here that this portion is more or less fluid. It is soft because the temperature is very high, so it is in a molten stage. So in this area there are currents, we call it convection currents. The hot material travels up to cool. And then once it cools, it travels to the bottom again. So it gets hot and so on. So by going into circles, always the hot part is below, and once it reaches a high temperature, it goes up, and once it goes up, it is affected by the low temperature, and the temperature is reduced, and so on. So the energy of the Earth is consumed by going into cycles. The material from below going up, and the material from up going below. So we'll come back again. What is a biosphere? A biosphere, this is the biosphere. You see here, at this is a portion of the crust, and the top of the crust, and the atmosphere. In the atmosphere there are birds, there are living organisms in the atmosphere, and there is living organism on the top of the crust, and there is living organism inside the crust. If you dig below, you'll find worms, you'll find insects, you'll find a living organism. So the division of this or this grouping is called biosphere. It means all the layers that includes living organism. Hydrosphere means all the layers that includes water. Here we have water, because water is in the sea, of course. In the soil below, there is water, because water penetrates the soil and goes below. And water goes up. By evaporation, it goes up, and you have the clouds. So hydrosphere includes the Earth's surface, the lakes, the seas, and it includes also part of the atmosphere above us. So this is the biosphere, and this is the hydrosphere. Another thing is called the lithosphere. What is the lithosphere? It is the rocky outer part of the Earth. It is made up of the brittle crust and the top part of the upper mantle. The lithosphere is the coolest and the most rigid part of the Earth. It is thinnest at mid-ocean ridges. By the way, the lithosphere and the definition of the lithosphere is very, very important, because it affects many of our studies later. What is important about the lithosphere is that it includes the layers that are affected by the tectonic movement. You know what is tectonic movement? You know earthquakes. how can earthquakes, or what is the cause of earthquake? Earthquakes happens when parts of the outer layer of the earth move relative to each other. So when they move, there is energy, friction between these layers. So energy is generated, energy wants to come from the bottom to reach the top. So the layers move relative to each other, and this starts a shake of the ground, and this is the start of an earthquake. So tectonic plates are part of this lithosphere. So as a summary, biosphere is everything related to biology, hydrosphere is everything related to water, lithosphere is everything related to rocky parts of the, or solid parts of the top earth, of the top of the earth. So it includes the lithosphere, the crust and the upper mantle, but the lower mantle is not part of the lithosphere. Just a photo I know that I gave you a lot of terminologies, but I will try to group them now. If I look at the earth from the top, this part is the lithosphere because it is the rocky part or the solid part of the earth, where we find the seas and the lakes, and so this is called the hydrosphere. What about the biosphere? We said the biosphere, everything related to biology. So in water, there is living organism. In soil, there is living organism inside the soil. On top of the soil, there is living organism on top of the soil. So this is the biosphere. So this is the biosphere. This is the lithosphere. This is the hydrosphere. So let's discuss what does the lithosphere consist of. Lithosphere is where is this rocky part of the, by the way, this is what we are going to study later in geotechnical engineering. We are going to, we deal with mainly the lithosphere. What does it include? The lithosphere includes soil, rocks, and minerals. What is the difference between these three? What is the difference between rock, soil, and minerals? Rock is the rocky part. Rock, you all know what is rock. Rock is the big masses or big materials that are found on top of the earth crust. This is the rock. When this rock disintegrates, it changes into soil, small particles. So sand, gravel, and these are all called soils. But rock is the main origin of this soil. But what about minerals? Minerals, we go a little bit inside the rocks and inside the soil. The mineral is the constituent of the soil. If I tell you that this is soil, you will tell me that this soil consists of molecules of materials combined together. So the minerals is the naturally occurring inorganic substances. Sometimes we may find minerals alone. If I tell you that this is a salt, salt is it's one kind of mineral. So this is a mineral. But if this mineral combines together, it may form soil. And if this soil changes with pressure and temperature, it may change to rock. And by the way, there is something called the rock cycle. What is the rock cycle? The rock cycle is the change of rock on top of the earth. The earth started as one big rock. And with time, the outer layer of the rock started to crack, disintegrate, and change it into soil. So we started to have rock and soil next to each other. Then with time, some of the soil it goes deeper into the earth, it goes near to the high temperature. Once it goes to the high temperature with the effect of pressure, it changes again into rock. And this rock with time, it comes on the top and disintegrates and so on. So there is a cycle for the rock, changing from rock to soil and then from soil to rock and so on. But this cycle takes millions of years to happen. We are going now to study each part. I will stop here for this and then start another part.